Hello friends, welcome to Risingpearl.com. Today we are talking about series 4 where we are looking at applications of trigonometry. This is webisode number 5, and friends, today's topic is solving problems related to heights and distances, part 3. This is part 3 because at webisode 3 and 4 they were the part 1, part 2, and this is a continuation from the earlier webisodes. So friends, like I have mentioned earlier, it is so very important to memorize this table of all the 6 trigonometric ratios: sine, cos, tan, cosec, sec and cot for these specific angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. And as you can see, I'm repeating whenever I get opportunity. I'm repeating this table. I'm showing this table in front of you so that you can, whenever you get a chance, you can look at this table and make sure that you remember these values, especially the one which is highlighted over here. If you know the values for sine, cos and tan for 0 degree, 30 degree, 45 degree, 60 degree and 90 degrees, then you can derive cosec, sec and cot, because cosec is nothing but reciprocal of sine, sec is nothing but reciprocal of cos, and cot is nothing but reciprocal of tan. So that's it friends. Let's take a look at some more examples, some more types of questions on heights and distances where we can apply trigonometry. This is question number 5. Question number 5, because we are actually having a running count. We saw 4 questions in the earlier 2 series. So now in this question, what is given to us is this: as observed from the top of a 60-meter high lighthouse from the sea level, the angles of depression of 2 ships are 30 degree and 60 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the 2 ships. So first what we are going to do, we are going to first draw ourselves a straight line, and we will say this is AB. And as you can imagine, yes, this is our lighthouse. This is our lighthouse, and it is given that it is 60 meters. So this length is 60 meters. AB is the lighthouse. Next up, what is given is somewhere in the ocean or in the sea, somewhere there is a ship. So let us say there is a ship at point P. There is a ship at point B, and we are standing at the top of the lighthouse looking down. Now we know that whenever we are looking down, then the angle which is formed between the horizontal, I have drawn a straight line parallel to the horizontal at my eyesight level, at our eyesight level. Now the angle formed between the horizontal and AP is my line of sight for the ship at point P. This is the angle of depression. So angle of depression is nothing but the angle formed between the horizontal and the line of sight when we are looking down. We saw this in our webisode number 2. Now, so for the first ship, my angle of depression is 60 degrees. Okay. Now, let us join BP, because BP, what is BP? BP is basically, so AB is the lighthouse and P is the position of the ship. So this is actually BP distance away, and this is 90 degrees. Why? Because we have discussed this again. We are going to assume that the lighthouse is standing straight vertically, that is, it's perpendicular to the ocean or to the ground. Next, there is one more ship which is somewhere further down in the ocean on the same side of the lighthouse. It is not on the other side, it's on the same side where the ship P is. Let's call this ship as Q, right? The position of that ship is Q. And also what is given is that the angle of elevation, the angle of depression I should say, that is this angle is 30 degrees for this ship, meaning the angle formed between the horizontal and the line of sight for this ship, that angle is 30 degrees. Now let us join PQ. Why? Because we would want to, it is given, we need to find the distance between the 2 ships. We are trying to find the distance between the 2 ships. So P is the first ship, Q is the second ship. So the distance between the 2 ships is PQ. So now let us write down what we know. So AB is actually 60 meters, that is given. Now the angle of depression for the first ship, this is actually very important to understand friends, is that Now let's say you have two straight lines, two parallel lines I should say, and you have a transversal that cuts both the lines. Now this angle and this angle are equal. They are alternate interior angles and they are equal. So if you have two lines which are parallel and if they are cut by one transversal, then alternate interior angles are equal. This is a theorem, friends, that we have seen in earlier classes, earlier grades when we were doing lines and angles. So here what we have is, this is very important for these angle of depression questions, because here we would want to convert this angle is actually equal to this angle. So angle P is 60 degrees. Why? Because let us just arbitrarily take a point, let's call it point X on the horizontal. So AX is parallel to BQ and AP is a transversal. So AP actually intersects the two parallel lines AX and BQ. So this angle and this angle should be equal. Similarly, you can argue that AX and BQ are parallel lines and AQ is a transversal. So this angle must be 30 degrees, should be equal to this angle, and so it should be 30 degrees. So at this point, friends, we know that AB is 60 and angle P is equal to 60 degrees. Angle Q is equal to 30 degrees. I just wanted to make one other point. It is not given that which ship is 30 degree and which ship is 60 degree. So when you have two ships, it is just common sense, if you think about it, that the ship which is closer will have a larger angle compared to the ship which is farther away. So if you have a ship which was even more farther away from the base, somewhere here, that will be even more smaller angle. Right? I just wanted to quickly clarify that point before we move forward. So at this point, friends, what you can see is that we have two right triangles. So we have right triangle A, B, P, and we have a right triangle A, B, Q, right? And we know the length AB, so we need to find out PQ. We are looking to find out PQ. That is what we need to find out. Our strategy will be, we are going to find out BQ, the big length, then we are going to separately find out BP, the small length, then PQ will be equal to BQ minus BP. That is how we are going to approach this question. So first we are going to take a look at this small triangle in this triangle ABP. So we are going to focus on this triangle ABP. So in this triangle, what we have is that we would need to understand, so this is 60 degrees. Now we are trying to find out this length. What is the relationship between these two sides for this angle? Well, the relationship is tan 60 degree is equal to 60 divided by this. So in other words, tan 60 degrees is equal to AB divided by BP. Now tan 60 degrees is equal to square root 3. We know this from the table. Tan 60 is square root 3. AB is 60. So we have 60 divided by BP equal to square root 3, or BP is equal to 60 divided by square root 3. That is, we take BP this side and this comes down. Now we would want to rationalize this. Normally we don't like to keep a rational number in the denominator. So then BP is, so this will become 3. So let us just write it here. So BP will be equal to 60 times square root 3 by 3. Then 3 20s are 60. So 20 square root 3. So what we have is, we have BP is 20 square root 3. This is BP. Now similarly we have to find out BQ. To find out BQ, what we are going to do is we are going to clean this up a little bit, give ourselves more space. Now we are focusing on this triangle. Now we are focusing on ABQ, the bigger triangle, ABQ, that is this triangle, ABQ. So here we can say that tan 30 degrees, which is basically this angle, tan Q, is AB by BQ. Is AB by BQ. And why am I not using sine or cos? Because sine or cos will get into the hypotenuse, right? But there is no mention of the lengths for hypotenuse. So we do not need that. What we're trying to find out is the relationship between, for both of these angles, this is the opposite side and this is the adjacent side. So we are looking for a relationship between opposite sides and adjacent sides, and tan is the trigonometric ratio that gives it to us. So here, continuing forward, so tan 30 degrees is 1 by square root 3. That is the value of tan 30 degrees. So we have AB, which is 60. Let's write it here to save some space. So AB is 60 divided by BQ. Or in other words, what we are seeing is BQ is equal to 60 times square root 3. So this goes here, cross multiplication. So BQ is equal to 60 times square root 3. So the whole length from here all the way till here is 60 times square root 3, and BP is 20 times square root 3. So PQ, which is what we want to find out, PQ, this is what we wanted to find out, the distance between the two ships is BQ minus BP, which is BQ is 60 square root 3 minus 20 square root 3. So this will be equal to 40 square root 3, this many meters. Again, in the interest of the time, I'm not actually going to do this multiplication. You can simply replace the square root 3 by the decimal representation up to maybe 2 or 3 points of decimal and do the multiplication. So this is how, friends, this is the first example that we wanted to take up. In the last two webisodes, we have looked at all kinds of questions, but mostly involving angle of elevation. So this is the first time we are looking at a question that involves angles of depression. Let's take a look at maybe one more question before we wrap up this presentation. So here, a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression 30 degrees, which is approaching the foot of the tower with a uniform speed. So what is given is that there is a car which is approaching a tower, right? There is a straight highway that leads to the foot of a tower. A man is standing at the top of the tower, observes a car at an angle of depression, because the person is standing at the top of the tower and he's looking down on the car. So the angle of depression is 30 degrees. But the car is moving and it is approaching the foot of the tower. So it is approaching towards the tower at a uniform speed. 10 seconds later, the angle of depression of the car now is 60 degrees. Because the car has come a little closer to the foot of the tower, so the angle of depression has become 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. So this is a very interesting question. This is it sounds like a little bit complicated question. So let's break it down. First, we draw a tower, right? We have drawn ourselves a tower, and let's name the tower AB. So this is our tower, AB, right? Next, we draw a straight line, which is the ground, and let us say initially the car is here at point C, right? And from the top of the tower, when we are looking down at the car, AC is the line of sight, right? And then I have drawn a horizontal line here. Remember, the person is right here at the top of the tower. So person is here and is looking down. AC is the line of sight, and this is where the car is. So this angle is given as 30 degrees, right? And we have just seen from the last question, if this angle is 30 degrees, it means this angle is 30 degrees. Why? Because this line horizontal is parallel to this line, right? And this is a transversal, so alternate interior angles are same. So now the car which is at point C is continuously moving towards the foot of the tower. The car is moving in this direction. So after 10 seconds, it is given that after 10 seconds, now the car is here. Let us call this position as position D. And at this point, the angle of elevation, angle of depression is 60 degrees. So this angle is 60 degrees. If this angle is 60 degrees, it means this angle is 60 degrees. Same reason again, this is horizontal line, BC is a horizontal line, and AD is a transversal. So this angle is equal to this angle. So we have now, and we know this is a right angle, right? Because this is the tower and this is the road. So now the question is that the car continues to move forward, and at some point the car will be at the foot of the tower. So the question that we are asked is, find the time taken by the car to reach the foot of the tower. We have to find out how long will it take for the car to actually get to the foot of the tower. So this is an interesting question in the sense that this is not asking us directly to measure any distance. This question is asking us to find time. So we have to have, this question is a combination of mostly math, but there is a little bit of a science element involved, because there is question of speed which is involved. Because we will have to use the concept of speed to find out how much time. Again, recall that speed is nothing but distance divided by time. So let's take it one step at a time, right? So what do we have so far? So we know that, so the car took 10 seconds to travel from C to D. So if somehow we can find out how much, so from point C to get to point D, the car took 10 seconds. It is given to us, right? So if we can find out CD, the distance CD, then we can find out the speed, because CD is the distance and the car traveled that distance in 10 seconds. So then we can find out the speed of the car. And then if we can find out BD, that is how much more distance is left for the car to travel, then we can use the speed. We can use the speed and the distance to find out the time. That will be our strategy. So now if you look at the triangle A, so we have two right triangles, ABD and ABC, right? So let us assume the height of the tower, which actually is not given to us directly, right? It is not given. Let's say the height of the tower is h, right? If you look at the bigger triangle ABC, so we can say that tan 30 degrees is h divided by BC, the whole leg, right? Now tan 30 degrees is 1 by square root 3, or we can say that BC is equal to h times square root 3, right? So BC is equal to h times square root 3. So similarly, actually we can say that h, let's express this in terms of h. So h is equal to BC divided by square root 3. So we will just keep the h here and we will move BC on the other side. So h is equal to BC divided by square root 3. Now if you look at the smaller triangle or this triangle, This time tan 60 degrees is equal to h divided by BD. Now tan 60 is square root 3. So what we have is h is equal to BD times square root 3. So we have h is equal to BC divided by square root 3, and we have h, which is the same height, which is equal to BD times square root 3. The reason, friends, I wanted to express both of these lengths, that is BC and BD, in terms of h, because h is the common length. Correct? So h is the common length. So if I say h is equal to this and h is equal to that, so we can then say that this, which is BC divided by square root 3, is actually equal to BD times square root 3. In other words, we would need to give ourselves a little bit more space. So let's say here, so we have h is equal to BC divided by square root 3, and also we saw h is equal to square root 3 times BD. Now from this we can express BC in terms of BD. So what we can say is that, so if these two are equal, if this is equal to this, so we can simply take the square root 3 on the other side. So we will be left with BC is equal to square root 3 times square root 3. It will be 3 times BD. Now let us say BD is x. So BD is this distance, right? Which is what the car actually has to travel. This is the distance. So let's say BD is x. So we will say that BC is equal to 3x. Right? Why did we put BD equal to x? Because remember that we eventually need to find out BD, because we would need to find out how long will the car take to travel from point D to point B. So let us say BD equal to x. So BC is this. Now what is given is that in 10 seconds the car moved from C to D. Right? So what is the speed of the car? Speed of the car is distance divided by time. This is, we know this from science. Speed is distance divided by time. So that the distance CD, the car covered the distance CD in how much time? It covered that in 10 seconds divided by 10. Now what is CD? CD is nothing but BC minus BD by 10. So if you look at this, so you have CD, which is this length, CD is BC divided by BC minus BD. Or in other words, we can say that BC is 3x, right? 3x minus BD is x divided by 10, or we have 2x divided by 3x minus x is 2x divided by 10, or we can say it is x divided by 5. So the speed of the car, even though we did not get a number, we got this in terms of x, which is the distance, how far, which is BD, which is how far the car is from the bottom of the tower. Now we need to find out the time taken to reach the bottom. Now, so the time taken to reach the bottom is equal to, so if speed is equal to distance divided by time, so the time is equal to distance divided by speed. So again, just from a formula standpoint, if speed is distance divided by time, so you take the time on the other side and speed comes down. So time becomes distance by speed. Right? Now, what is the distance we are trying to find out? So the time we are trying to find out is how long will it take for the car to travel from D to get to B. So the distance BD is x, that is what we have assumed, right? Divided by what is the speed of the car. Speed of the car is available, this is the speed of the car which we just found out. So that will be x divided by 5, or in other words, x and x will cancel out, it will be 5. So 5 seconds. So friends, even though we did not have a lot of data here, but applying mostly trigonometry, trigonometric ratios, and in this particular case also taking the help of linear equations in 2 variables and also some science physics concepts, we have found out that the time taken for the car to get from point D to the base of the tower will be equal to 5 seconds. So friends, I hope that you have been following us along, and especially in this series where we looked at how we use trigonometric ratios to solve heights and distances questions. And I strongly also suggest that if you have not got a chance to take a look at all the videos for series 3, which were really the foundations of trigonometry, so I would strongly urge you to go and take a look at those videos. So the next video we are going to basically wrap up our series number 4, applications of trigonometry.